So now that the engraving is done and I fit the mod kit, we can start putting everything together. The first step is to protect the valve threads because the casing threads can get damaged in working in the shop, soldering. I'll do some grinding and hand finishing and polishing. There's a lot of stuff that happens that could potentially damage these. So I have machined protectors, and I've used these for decades really. But I have custom machined protectors for the top and the bottom. We do sell these in case you are cleaning your horn and you're at home and you're gonna put it in the bathtub, or some people even put them in the dishwasher, and you want to protect the threads. We do sell sets of those. That was the top caps. We'll put the bottom cap protectors on, and then we'll be ready to get started soldering. And I've already cut most of the tubes, so most of the busy work that you normally would see me do has been done, so you don't have to watch me cut every single tube. That's what it looks like protected. And let's get started here. Now I have very specific dimensions for the Summit trumpet. This lead pipe, of course, is a very specific design and length. The VGR receiver or the ZGR, the zero gap receiver, whichever one you choose, those are already pre-engineered and cut on our CNC lathe to fit this exact lead pipe. And a tube gets inserted into here and soldered in place as well. But we just have to check some basic things, the basic fit, make sure everything's going to line up. We can see that when I put that up against the valve set, it did print exactly as it should, and it's a perfect match, it's a perfect fit. So that's important. And then that would of course line up with the tuning slide, and then this bottom tube that is the bottom leg of the tuning slide. And finally, on the back side, we have some things to work out with the bell crook, and all of those parts have been pre-cut and pre-done because that's how I planned it and that's how I've done it. And that's because these are done on the 3D printer and the metal printer, and the other parts are CNC machined, and a few things can be hand fabricated at times. But that's in the CNC machine shop next door. So I have to design and plan all that stuff usually months in advance before I put something like this together. But the G5, the prototyping and all the work to get here has actually spanned almost 3 years. And like the mod kits, the bottom caps and top caps and things you saw earlier, those I actually machined 2 years ago, maybe a little over 2 years ago, for today, for this project, for the 2026 launch. So let me find all the parts. We're going to go with Saturn water keys on this, so I'll grab those, and I'll grab all the tubes that are necessary and see if we have to cut anything, and then we'll begin soldering. Okay, so I have the Saturn water keys. If you haven't seen these, they get mounted, and after they're installed, you can press the ring from any side towards the center. That black ring is the Saturn. So I have a number 3R bell, and that bell is going to fit into this bell crook. But you can see they don't actually fit. There's an in-between that has to fit there. There's a coupler, and I machine a special coupler for every bell. So each bell taper is different, and because they are, that diameter is different, which means I need to have an interface for each one. And that's why you'll see this brass coupler mounted against the stainless steel. In the previous third generation, you would see the machined bell crook with this coupler in between. And that's why that happens. And you can see here, I've got a whole array of bell crook couplers that I've already machined for different size bells. We'll put that away, and then I'll show you the rest of the setup. Now on the bell crook, because this is essentially completing the final bell taper, we have this coupler at the top, and then we have a coupler at the bottom. And the coupler at the bottom comes in two pieces. The first piece is right here, and it just blends it together. so that it comes to here. Now this last little piece is the bell choke. This bell choke, this is a 460, but it can come in different sizes. So I have here multiple sizes. I've got a 440, a 450, 445, a 420. I also make a 430. When you reduce the bell choke, you'll get more vibrancy in the bell. So that is an option. It's not extra to choose your bell choke. If you're playing in a situation where you want more vibrancy, more color, or let's say you're playing lead in commercial and you want more zing, then you want to go with progressively smaller bell chokes. If you want the brightest possible, then you're going to look at a 430 or a 420. So those are options. Those have always been built into the Summit series. The third series always had that option, and the fourth we just carry it straight over. So this one we're going to not choke it, which means we're going to use the 460. That's the one I had in there, and we'll solder all this together, and then we'll also solder the legs of the tuning slide. So I've already got them pre-fit, and those will be soldered in place, as well as the water key. Now the water key is a Saturn, and that's the only option you have on this tuning slide. So you cannot choose a different variation, and that's because, as you can see, when I'm done, it'll be a perfect fit. I'll flux it and then tap that in place, and it fits in there perfectly. So that's the only option there. And then on the lead pipe, we do have a brass tube that fits into the lead pipe there, and that'll be the receiver for the tuning slide. So that way it's the precision brass on the precision ground nickel, and this will be the VGR receiver for the lead pipe. As you can see, it's the adjustable system, so we can adjust flexibility, sliding, airflow, and get an impedance match, and that fits right there. I'm going to go solder all this, and I'll let you watch. So now I have all the parts ready to solder. I just need to add the flux, and these will go together. The water key will go in. There's the bell crook and the lead pipe. We're going to start with the tuning slide, and that gets some acid. This acid is specific to soldering brass, nickel, and stainless steel. So it's a lot different than a standard flux. And because it is so caustic and corrosive, I don't want to breathe it, so I'll have to open the door, and I'm wearing my respirator. And of course, don't do this at home. And this is a custom-made 3D printed spanner that keeps the tubes parallel.
Next is the bell crook. So I put acid on both parts. And this section gets soldered with that special flux and solder, and this section is standard solder. So here's both on this one. I'm going to set this aside for a minute and go back to the tuning slide, which is still pretty hot. I can cool it off. So now it's cool enough that I can hold it. And now I just put a little acid in that Saturn area, and I put some on the Saturn and pop it in place. This is a very tight fit, so I'm going to tap it in place with a nylon mallet. Alright, that's it. This one takes so little solder, just a tiny, tiny bit. And that's it for the Saturn. There's so little solder that there's really nothing to clean up. Okay, so the tuning slide is done. Now we can go back to the bell crook, which is not too hot. Add some acid to the top and to the bell coupler. Alright, so now the bell crook is finished. Next is the lead pipe. We'll start with the receiver. The receiver is very delicate, so I want to make sure I don't get too much heat on it, because I could damage it. Now the trick is to get that solder to flow all the way to the top. And there it did. It just flowed out the top of the receiver. I don't know if you can see that, but it's coming right out the top. Now I can clean it up a little bit. So most of my time is spent cleaning this up. Alright, I've cooled it down enough to touch. The last component is the tube. And again, acid. Now this we're going to do a little different. I'm going to feed some solder in, and then I'm going to push it in place. There it is. It looks good. Now we can turn that off. Here's the lead pipe. There's the VGR. And I'll do some cleanup on these, obviously. That's still kind of hot. Bell crook. And the tuning slide. The next step is to solder these tubes onto the trumpet, which will go right here. I'm going to clean this up, which requires just a little bit of scraping and then a little bit of polishing.
So we'll do that next. You can see there's a little bit of solder on the edges, and that has to be perfectly clean before I can put it into the other tubes. Now scraping on this is very, very easy because I have engineered everything to fit perfectly together. Previous generations were not so easy. And that's mostly because inside these tubes, inside the tuning slide, is a labyrinth that the solder follows. So I engineered that and printed it. Whereas when I made these from CNC machine tubes, we could not machine a labyrinth inside the tube. That wasn't possible. But since it is, I took advantage of that and included it in the design, and that makes cleanup much, much faster. Now, I also need to scrape and clean up this belt crook as well. So I'll just do a little of that right now. I wiped most of it off while it was hot. The cleaning phase of building our trumpets is always the longest time-consuming part of the process. That and the engineering. Of course, the engineering takes decades. All right, so that's mostly done. And we'll come over here and clean this up. So it's pretty much clean. Now I just need to polish it a little bit. We want it to be nice and smooth. All right, that looks good. Let's take a look at it. Okay, so that is ready to go. So we want everything really, really clean. That way we don't introduce any debris or foreign matter into the slides or the pistons that could scratch them. We don't want scratches. So now we've got that fit together. Now we need the lead pipe to fit together. And that would fit right here. And we want these to match up. So as you can see, if I put it all together, we can match it all up. But this is not clean yet, so let me go clean that. So I spent some time cleaning everything up, just because that's easier at this step to get it all cleaned up and ready to assemble. So internally, externally, everything's cleaned up on the tuning slide and the water key and the bell crook. See, that came out really nice. It's really beautiful to see the brass against the stainless steel. And the inside is perfectly cleaned up, all brand new. Same with the lead pipe, that's all ready to go. perfectly clean and tuned up, ready to install. So at this point, all I'm going to do is a light swab inside any of the tubes, since I ran them through a whole course of cleaning, and make sure everything is clean there. And we'll do this one too. Okay, so now we just want to put everything together. So I've got the tuning slide and the lead pipe, perfect fit. And then this tube on the bottom, that's what we call the bottom leg of the tuning slide. It connects it to the third valve. And we want this spacing to be perfect. So as you can see, space right about there is perfect. And I haven't really fine-tuned this yet. So looking at that in the future, I might actually make this leg a little longer, maybe a 3.7 instead of 3.6. So the one thing I need to consider is that everything is perfectly clean before I assemble it. And on this valve casing, there's a little tarnish there, so I'm going to just clean that up where the braces are going to touch, which is not really everywhere. It's just these two braces here and the bell brace. And that way when I flux it with that acid, it's very, very clean. That looks nice. And then after we solder this on, we'll do the water or the finger rings, and we'll do this third water key, and then we'll put the bell crook and the bell on with the brace on the backside. So next step is to take this next door and get it soldered up. So my phone battery died, and I grabbed my action camera. This is a new one I've never used, so hopefully I'm not covering up the microphone. I got everything soldered together. I don't know how much you could see because I don't know when the battery died, but those are the solder joints, and it turned out pretty clean. Looks very nice. Let's check that tuning slide, see if that moves okay. It does, so we're good there. The next step is to put the bell on. So let me get this back up here. I'm just going to set the camera down and see if maybe you can follow along this way. Take this bell clamp off. We need to get the bell crook in the correct place, or we could do the finger rings first if we want. Let's do the bell crook. Since I already have everything laid out here. A lot of times I can do both of these at the same time, but filming does take more time and is a little more tricky. Now, one of the reasons that I put the brass parts onto the steel on the bell crook was so that when I do this part, I don't have to deal with that acid and reassembly. I can do all the assembly over here. So all I have to do is flux these, and then get everything lined up, clean a little spot of the bell, and then solder. Oh no, I still need to flux something. The brace that goes on the second slide, that needs to be fluxed with acid rather than this standard flux. It's that caustic acid I showed you before. So we'll get this lined up. That's perfect. And then we just have to add that brace. I'm gonna go grab the brace right now. And that is this little guy right here. So with the new camera, I don't know how things are gonna focus or what it's gonna look like, but this is the little brace that's gonna go right there, and then everything will go together. So I just need to clean up this brace so there's no oxidation.
All right, we're good. We're ready to go. Look at that. Pretty nice. So I think that turned out pretty nice. Yeah, that's a beautiful joint right there. That's what it looks like from the top. And you can see on this model, the bell is free to vibrate. So you get a ton of resonance once you get the impedance match. And it's so light. So we're going to go with stainless steel. These are extremely lightweight, very strong, and they're the ergonomic style. I need to check the radius of each one because they were 3D printed, and when they're printed like that, depending on the orientation of the print and where the supports are, there could be something that needs to be removed. All of these look perfect. Got 3 clips, got the rings. Let's go next door, solder them on. This is going to look really amazing. This will be the first time I've ever used the stainless steel finger rings, and it's something I've wanted to do for a very long time.
Right, that turned out pretty good. It's the first time soldering those finger rings, which are, the stainless steel is always harder to solder. It's one of those things where it wants to oxidize so very easily. And the reason it's hard to solder, see I'm touching it already? It's because it really doesn't conduct heat nearly as well as brass. So when I heat up an area, I have to heat it up a lot, but if I heat it up too much, it'll oxidize, even with that acid in there, because that acid creates a vapor barrier against the oxygen. If I heat it too much, the acid evaporates and vaporizes and is gone, and then oxygen gets in there. So I have to be very careful that that doesn't happen. So you got to get the heat just right, but it never wants to heat up, and this area has more mass. So that lead pipe area, because it's got like this as a heat sink and this as a heat sink, and it actually has a built-up section that's heavier. So that one's the hardest one. And then it's hard on these too, because the steel needs to take more heat than the brass. So if I overheat the brass, it can oxidize. And if I overheat the steel, then that can oxidize. But I need to heat the steel more than the brass, which is why you'll see me soldering from the top down, which is normally not what you do. Normally you go for the most massive area and you get that first. So that was a little bit challenging. I'm glad it worked out. Everything looks nice. This trumpet is so incredibly light. And I did another one that didn't have, it had, no, it had the same as these. Had the same empty tuning slide and bell crook, but it had the up bell. And that one also was extremely light. Like, it just feels like, you know, for it to be such a high efficiency horn that projects so well and plays so easy, it's crazy that I got it finally down to this weight, where the only way I can really reduce the weight now is to start machining, printing and machining the valve sets without the first, second, and third slides, which is something I'm working on, and just minimizing the components in the instrument, which is coming in a couple years. But man, this is crazy. It's so light, it feels so good. I put that third ring out quite a ways because I know a lot of you are going to test it this way, even though I hold it this way. If it were for me, I would have pulled it in really close. But put it out like that, and yeah, that's pretty cool. So it's Saturday, and I'm going to go home and enjoy the rest of my weekend. But we won't be able to finish this today. Monday morning, I'll come in and solder the braces that fit here and this water key, and then I'll clean the whole thing up and play it, and I'll record all that, and then this video will probably go up on Monday. So you're probably watching it Monday night if you're one of the first ones. Yeah, that's it. That's all for today. I feel really good about it. You know, for it being the first one for 2026, it went together pretty smooth. It's so minimalist compared to what I've done in the past. And remember, I was never trying to be complicated. Well, sometimes I was, but a lot of times I wasn't. I was trying to simplify. It's just that when you're machining or hand fabricating, making it very simple and lightweight is very, very expensive. And with 3D printing, well, it's even more expensive, 3D printing. But with that said, I can 3D print it, and the print will run while I do other things, and I don't have to babysit that process. So there are advantages there. But the cool thing is now we can produce these thin walls and these braces that are extremely efficient and create a lot of efficiency throughout the instrument, so that the standing wave and the antinodes don't convert into vibration until they get to the bell. And man, I can't wait to play this one because I know it's going to resonate like crazy. All right, I'll see you guys on Monday. All right, so we're back to the trumpet. I did get all the finger rings on, and I did get the braces on. This brace is the one I showed you before, and now I need to trim the screw to be the exact length. So I'm going to do that first, because we want that screw to stop the third slide, but not actually impede the movement. And it looks like it's just a hair long. Probably just a few thousandths. Okay, I can see light between there now. So that's good. I'll just polish it up and be done with the screw. That's perfect. And on the first slide, originally I was going to put in a similar type brace, but it didn't fit, and I looked at it closely to figure out why, and that's because I had designed that brace for a standard bent bell tail, and I didn't adjust it for this tapered machined bell tail. So that means I need to design another one and print some more that have the right spacing to fit this tube and then this slightly tapered larger tube, which is only 20 thousandths bigger, and it's a taper. I wrote down the specs, and then in the next print job we'll do that, print that, and on the next one we'll have it right. Okay, so now I just need to clean the whole trumpet up, and I have a few options here, you know, because this isn't for a customer. I can choose to either finish it brushed, like brush the whole thing, or I can polish it, and there are advantages to each. Oh, I see, I haven't put the third water key on, so I'll do that too. And I have to figure out what I'm going to do. Am I going to brush it, or am I going to polish it? And I think on this one I'll probably brush it. Oh, and I also added the 30th anniversary logo, which is right here. So it's got my signature underneath, and it says 1996 to 2026. And since this is just a test, it's not very big. On the next one I'll probably make it quite a bit bigger, because it could fill, you know, maybe the space of an inch or more, and it looks nice. So that is what I have on here. The last thing I want to engrave on here is the number for this year, and this is something I'm starting just this year. I'm going to engrave the serial number, which I've never used before, and that serial number is going to coincide with just the year. So this will be 2026 number 1, and throughout 2026 I will have numbers, and when I get to 2027 I'll start over with number 1 again. As always, you can tell any previous models by the serial number by the date. So the date has always been this specific serial number on our trumpets. So let me do this water key, and then I'll move on to that engraving, and I'll make a note here to engrave it. We'll just do 2026 number 1 as the engraving. Alright, so first thing, I need to get a Saturn on this third slide. And I already have the Saturn base here prepped to go. Okay, that's done. So I have the water key done, and I have the engraving right here. I'm going to start brushing this, and first thing I'm going to do is go over the whole horn and see if there's any solder that can be scraped, because scraping is a lot faster than sanding. So let's sharpen the scraping tool. As you can see, the cleanup is kind of the hardest part. Can you grab some sideways? Thanks. 4. How'd your day go? Good? Almost done? Makes me a little bit more happy. Yeah. I feel like it's like the rest of the day. And I'm seeing on Friday, so I'm going to make sure I get an extra couple days late in for that. Today and tomorrow. Okay. Thanks. Right. Yeah. Check on that one. Excellent. Let me put this inside and then we can take this. Trumpet. find something for it. There's a lunch in the closet in that storeroom. Okay. This room. I need to put the screw in, and then it's done.
It looks really good.
Yeah?
What do you think?
I think it looks nice. Let me just clean this up quick.
Yeah, it looks really good.
It is done. It looks pretty cool, huh?
Looks really cool.
Can hold it from here and it won't tarnish. It's fairly light.
It looks really good.
I'm gonna go weigh it. Yeah, it does look really good, doesn't it?
It's nice. I mean, it's not like it hasn't been fun having all these different horns, but it's nice to have a fully metal horn.
I know.
I'm like,
Seriously.
oh, it looks really good.
I'm kind of excited to have metal horns again. 2 pounds 11 ounces with that setup. So it could be a little lighter. Probably, it's probably possible to get it 2 ounces lighter if we wanted. Just with what we have. That's the lightest we've had.
Looks really sharp.
Like that's the lightest horn I've built in many years. Yeah, decades. It's only 3 ounces heavier than a Bach.
Well, that'll sell. That'll be helpful.
Yeah. I did it.